So same thing, today we are already at lesson 3 for magnets, and we are going to go through even more content on magnets. Okay, now we will start off. I know usually we have a video at the end, but today we'll start off with a video first. Specifically is to act as like a more like a recap on the knowledge as well as the content with regards to magnets topic. Now, just for Jaden's sake, okay, we're just going to go through the rules very quickly. Okay, I know the 3 of you are very familiar with it. Now for Jaden, basically I think you've been doing well. You have turned on your video. That's very good. Now, another thing is you might just want to change your name to your real name. Okay, if you're not sure how to do it, there's 3 dots, right? There are 3 dots on the right-hand side of your video. You might just want to rename yourself. Okay, so that's another thing you need to do. Okay, then in terms of if you want to ask a question, you can always type in the chat. If let's say it's something urgent, you might also just want to raise your hand using the reaction. Okay, I'm going to demonstrate once to you. So when I raise my hand, I'll be prioritized first. So I'll be able to see you first, and I'll get you to ask questions or to speak up to answer questions or certain things. Okay, Ken? Then lastly, of course, if you need to go toilet, just drop me a text in the chat, because I think it's just normal for you to want to go toilet sometimes, right? If just want because you want to answer to nature's call, I will not stop you from doing that. But of course, within 1.5 hours lesson time, I don't think you should be going too often as well. Okay, so I think it's a lot about mutual respect, and also just be a bit more mindful even to other students in this class. Okay, you need to be able to respect them and to just just be mindful basically. Okay, although we are on a cyberspace, but then again, be a bit more considerate towards people's feelings as well. Okay, but I think this class has been doing fine, all of you. Yeah. Okay, now we're gonna watch this video first as a recap on magnets. Okay, because usually we always start with like a recap, then after that the video is at the end, right? So today we'll just start with the magnets video first. Okay, so I'm just gonna play the video. Okay, I think that was really quite comprehensive, and I think it's really interesting that they actually make it into like a show, right? Like a animated magic show. Okay, I think so.
That I'm black.
Sorry? Oh, why is your screen black, Kelvin?
Yeah, I don't know.
Usually you have your screen on, right? Do you want to just sign out and sign in again quickly? Abir, if possible, please turn on your video, yeah, Abir?
I'm trying.
Oh, something is wrong with your screen as well. Okay.
If you want to check.
Okay. Well, we'll wait a while for Kelvin to be back. So basically, I think that acts as like a recap. The main ideas, I would say that the content is not a lot. Jaden, have you learned magnets in school? Yes? Okay, great. Magnets is actually currently, the syllabus has changed if you're not aware. Basically, the primary 3 students this year, you're already in primary 4, so it doesn't really affect you. But the primary 3 science syllabus, when they are taking PSLE, they are following the new syllabus. Okay, so what happened is that for magnets, right? Magnets is actually considered a primary 3 topic. Okay, but then again, I mean, why we're going through it now? Basically, if you have learned it, take it as a revision. If you have not learned it, just take it as you're learning something ahead of school. Okay. So how, Kelvin, is your screen working? Okay, great. Maybe something is wrong. Same thing for Iber. If you need to, you can log out and log in again. Yeah. Okay, so we will go through the questions before we take a break at the 45 minutes point. Okay, then we can have some games later. Okay, so for this one, I think it's quite an easy question. The diagram shows a magnet brought near a glass block. Okay, glass block. So what does that tell us about? Okay, what does that tell us about the glass?
The glass is not magnetic at all.
Very good. Okay, so glass is non-magnetic, which means that will the magnet attract the glass? Yes, Aber.
No.
Okay, we
Yeah.
take turns to answer, okay?
The
Aber?
answer is A.
Yeah, okay, because I think Kelvin said no, it will not attract. And the reason is because it's a non-magnetic material. So basically the concept behind this question is that magnets attract magnetic materials. Okay, and some examples will be your school is not cool. Steel, iron, nickel, and cobalt. Okay, so since glass is a non-magnetic material, there will be no attraction at all. So basically it will not move. That's right. Good. Okay, let's move on to the second question. Melissa places a magnet close to a copper coin. Now, if you want to answer, please click on the raise hand function, yeah? So what is likely going to happen to the coin? Now, again, this one is copper. Okay, so what does that tell us about copper?
Not a magnetic material.
Very good, not a magnetic material. Okay, let me just change the color. So this is a non-magnetic. A lot of students get confused between copper and cobalt. Cobalt is magnetic, copper is not. Okay, non-magnetic material. So what is likely going to happen to the coin? Anyone wants to answer that?
Stationary.
It stays stationary. Okay, yes, D. Right. Okay. Remember to raise your hands. I think a lot of you like to answer questions, which is very good attitude. Actually, I like it that you take the initiative to answer questions. Okay, but you do need to raise your hands when you want to answer. Okay, yes, Aber, which one of these is not? So we are looking for
Copper.
crosses. Copper, yes. Nickel is, cobalt is, iron is, copper is not. See, we are looking for crosses. So it's copper. Again, the concept is the signs is not cool. Steel, iron, nickel, cobalt. I think this question, nobody get it wrong, right? Oh, one of you actually got question 3 wrong. Probably is careless mistake. Yeah, one of you got it wrong. Okay, so just to recap, steel is not, school is not cool. Steel, iron, nickel, cobalt are your magnetic materials. So which one is not? Is copper. Okay, next question is very similar to question 2. A diagram shows a magnet brought near a plastic block. Yes, Arano. What will
It will
happen?
not move.
Yeah, that's right. Okay, it will not move. So answer is B. I think that's a typo error. This should be plastic. Okay, I guess it will not move again is because it is a non-magnetic material. So there will not be magnetic force acted on the plastic block. Okay, good. Okay, first two question not too difficult, I would say. This one is, okay, this one, I think this one falls under materials. I don't think it's under magnets. Okay, just want to highlight. Okay, but we can still do the question. Okay, which of the following objects can be bent easily without breaking? Jayden. Kelvin, why are you upside down with your spectacles on your nose area? It looks like your mustache. Okay, Jayden, what's the answer for this question? When we talk about bending easily without breaking, basically we are referring to which property of material?
Flex.
Very good. Flex. Okay, you say flex. Flexibility. Okay, so of course, out of these 4 materials, which one is the most flexible? Jayden? Jayden, I think you need to unmute yourself. Have you unmute yourself? Because I can't see your mouth. Maybe you were speaking, but we couldn't hear you because you have not unmuted yourself. Oh, you typed in the chat, is it? Let me see. Your speaker is not working? Oh, okay. Jeffrey said C. Yeah, that's right. Okay, of course, out of these four, if you can see, the sheet of glass is not flexible at all, and metal spoon also, wooden ruler. If you were to bend all these three, they might just break. Of course, metal spoon might not break so easily. Okay, but it depends also. But towel is super flexible, right? Towel is very flexible. We can even wrench it, right? When we wrench a towel, it doesn't break. Okay, so it's very easily bent. Okay, next question, question 6. An object was attracted to a magnet. Object P is made of, Ariano?
Iron.
Very good. Okay, iron, because iron is a magnetic material. Again, is the concept on your magnetic material. Your school is not cool again. Okay, steel, iron, nickel, cobalt. Yeah. Okay, this one is quite straightforward actually. This question and the last 4 questions are similar. Question 7, also testing the same concept. Abir, which of the following can be attracted by a magnet?
Steel cup.
Very good. Okay, again, it's the same concept. Okay, I think by now you're very familiar with that already. Yeah? Okay. Now, next one is a bit more difficult. Okay, this one is definitely more challenging than all the previous questions we've gone through. Diagram 1 shows the mass of magnet M when it's placed on the electronic balance, meaning what's the original mass of the magnet? It's actually 20 grams. Okay. Now you do realize that when we put an object here, it seems like it got lighter. If it got lighter, means that it's actually a pull force acting on it. Something is pulling it up. Okay. And when something is pulling it up, means that there must be an attraction. Right? Because this thing is pulling it up. Okay. So now in terms of, okay, let me just, this is rotation. Yeah, okay. So in terms of pulling up, of course, the material of object Y. So that means that suggests that object Y is probably a magnet. Okay. In terms of the material, of course, if you want it to be a magnet, it must also be made of magnetic material. So that means copper is out because copper is a non-magnetic material. Okay, your magnets are all made of magnetic material. Yeah. So what is the magnetic force that was acting on Y? If you look at the magnetic force acting on Y, it's basically an attraction. So the direction of the force is actually going up. Okay, it's trying to exert an attraction onto object Y. Yeah, and then of course the material is steel because steel is a magnetic material, right? All these two are magnetic materials. So therefore, they can be used to make object Y, which is possibly and highly likely a magnet. So the answer is D. Are we clear? So far, okay? Are you lost? No? Okay. Now, next question. Timothy wants to find out. Now, the moment you see to find out, it tells you the aim of the experiment. So what does he want to find out? He wants to find out if the number of coils of wire around an iron nail will affect the strength of an electromagnet. Okay, so over here, the number of coils of wire around an iron nail, this one has got to be the change variable. Okay, the strength of an electromagnet, that will be your measured variable. Okay, so he's given 4 setups and some paper clips. Which 2 setups should Timothy use for his investigation? Okay, so in this case, the number of coils of wire around the iron nail is the thing that we want to change, right? So we will want to use one of them 10 and one of them 20. Okay, but you do need to take note. Yes,